Welcome to Learning with UNP. In this session of Business Intelligence with Power BI, we will look at Advanced Charts Part 1. Power BI provides a wide variety of visualization options ranging from basic to advanced charts. Advanced charts help in better understanding and interpretation of complex data by providing deeper insights. They allow us to analyze trends, relationships, breakdowns, and distributions effectively. In this session, we will cover the following advanced charts: scatter plot, God chart, funnel chart, tree map, and decomposition tree. We will use the Maven Market dataset for this demonstration. This dataset includes multiple tables such as Maven Market transactions, Maven Market stores, Maven Market returns, Maven Market regions, Maven Market customers, and Maven Market products. We will use columns from these tables to create insightful visualizations. So let's begin. Before we start creating visualizations, let's first understand what advanced charts are in Power BI. In Power BI, advanced charts go beyond basic bar and column charts. They allow us to analyze trends, compare metrics, and gain deeper insights into data. These charts help in decision making by presenting complex data in an easy to understand format. Now let us understand what is the use of advanced charts. Basic charts like bar, column, and line charts are great for single comparisons. But sometimes we need more advanced visualizations to analyze complex data effectively. Advanced charts helps us in identifying trends and patterns, compare multiple variables, track progress towards goals, and analyze hierarchical and process-based data. In this session, we will focus on 5 types of advanced charts that offer unique ways to visualize data: scatterplot, God chart, funnel chart, tree map, and decomposition tree. Each of these charts serves a specific purpose, and we will explore them one by one. Before we start building charts, let's first create a few key performance indicators (KPIs) that we will be using in our visualizations. We will create all the measures in fact table only. So the fact table in Maven Market dataset is transactions data. Click on the table, select new measure. Let's name this measure total revenue. Equals to, we will use the SumX function because we need to calculate the total revenue based on the quantity of products sold and their retail price. So type SumX, hit tab. We are creating it in transactions table, so type transactions. Here is the table, hit tab, comma, type quantity. Here is the column, hit tab. We have to multiply quantity with product price, but we don't have price column in transactions data. We have it in products data. So to use price column from the products table in transactions table, we use related function. So type related. Here is the function, hit tab, type price. Here is the column, hit tab, close the brackets. Hit enter. Now we have successfully created our total revenue measure. Let's now create total cost measure. Again click on the table, click on new measure. Let's name this measure as total cost. Equals to, we will again use the SumX function, but this time we will calculate the cost based on the product's cost price. So type SumX. Hit tab. We are doing it in transactions data, so type transactions. Here is the table, hit tab, comma, type quantity. Here is the column, hit tab, into. We are again using cost column from products table, so type related, type cost, close the brackets, enter. Now we have our total cost measure ready. Now let's create the total profit measure. Click on the table again, click on new measure. Let's name this measure as total profit. Since profit is simply revenue minus cost, we will subtract total cost from total revenue. So type total revenue. Here is the measure, hit tab, minus total cost. So type total cost. Here is the measure, hit tab, enter. Now we have all the important KPIs needed for our charts. Let's start building visualizations one by one. Let's create another page and name it Advanced Charts. Hit enter. Let's start with the first chart, the scatter plot. The fourth chart in the third row is scatter plot. Click on the chart. A scatter plot is used to display relationships between two numerical values. Each point represents an individual data value, and its position is determined by the x and y axis. The parameters of the scatter plot are: x-axis represents one numerical variable, y-axis represents another numerical variable, values represents the data points. Scatter plots helps in finding correlations between two factors like sales versus advertising spend, identifying clusters in data, and detecting outliers like unusual data points. For our example, imagine you have total revenue and total cost for each product. A scatter plot will help you see if higher costs lead to higher revenue or no. Here is how we create a scatter plot in Power BI. Click on the chart, drag total revenue measure onto x-axis and drag total cost measure onto y-axis. And let's use product name from products table as values. Drag it to values field. And let's drag total profit onto size. Let's expand the chart for better visibility. Let's try to reduce the size of the bubbles so that it is visible clearly. Click on the chart, go to Format your Visual, click on Markers. Let's decrease the size to 30. Enter. Now the data values are visible clearly. We can also try to fit a line and check the relationship. Click on magnifying symbol, put on the ratio line. We will adjust the color of ratio line. Click on it. Click on the drop down of the color. Click on more colors. Let's fix red color and let's change the line style to solid. Now we can see a proper line fitted among the data points. Over here, x-axis is the independent variable, that is total revenue. Y-axis is the total cost, that is dependent variable. Details is unique categories like product name. Size is a third variable that changes dot size based on total profit. So this is a scatter plot that helps us compare product performance easily. Over here, let's reduce the size of the scatter plot. Now let's explore the GOT chart. The fifth chart in the fourth row in the visualizations pane is the GOT chart. Click on it. The GOT chart is useful for showing progress towards a goal. It visually represents how much a metric has achieved compared to a target. A GOT chart is simply a speedometer-like chart that shows progress towards the target value. The parameters of GOT chart are value, the actual data point that is displayed on the GOT's needle; minimum value, the lowest point on the GOT scale; maximum value, the highest point on the GOT scale; target value, the desired value on the GOT, often visually highlighted. GOT chart is used in measuring KPIs, tracking achievement versus a goal, and monitoring business performance. Before we dive into an example using GOT chart, let's create a new measure for our target value. Click on Transactions table, click on New Measure. Let's name this measure as Total Target Value. Equals to, let's enter target value as 15 lakh. Hit enter. For our example, if sales target is 15 lakh, a GOT chart will show how much we have achieved so far. Here is how we create a GOT chart. Click on the chart, drag total profit measure onto value field, and let's drag total target value measure onto target value field. Over here, value is the current metric, that is total profit, and target value is the ideal benchmark that we have set using a measure. Now, this GOT chart visually shows how much profit we have achieved compared to the set target. Next, let's explore the funnel chart. The third chart in the third row is the funnel chart. Click on it. A funnel chart is used to show data that flows through stages in a process. This chart is useful for visualizing processes like sales conversions, where data moves through stages. The parameters of funnel chart are: category represents the different stages, values represents the numerical data for each stage. Funnel chart is used in visualizing sales pipelines, analyzing conversion rates at each stage, and identifying drop-offs in processes. For our example, imagine we want to understand which sales district contribute the most to our profits. Here is how we create a funnel chart in Power BI. Click on the funnel chart. Drag total profit to the values field. And drag sales district to the category field. Let's expand the chart for better visibility. Over here, category is a stage, that is sales district. Values is the metric being measured, that is total profit. Now we can see how different sales districts contribute to the overall profit. Let's create another page named Advanced Charts. Now let's look at the tree map. The first chart in the fourth row is called as tree map. Click on it. A tree map is a hierarchical chart that represents data as nested rectangles. The size and color of each rectangle indicate relative proportions. A tree map is useful for visualizing hierarchical data and comparing proportions. Parameters of tree map are: category for main classification, values represents numerical measure for comparison. A tree map is used in comparing sales across product categories, analyzing market share of different brands, and visualizing profit contribution by region. For our example, imagine if you want to analyze profit across different store types, a tree map can show which store type contributes the most. Here is how we create a tree map. Click on the chart, drag store type into category field, and drag total profit into values field. Let's expand the chart for better visibility. Color saturation helps in identifying high and low values. Over here, you all might have a doubt. Supermarket and deluxe supermarket is almost same in color. But let's look at the values so that we'll understand the difference between them. So, the total profit of supermarket is 4,71,065.15 and the total profit of deluxe supermarket is 3,99,659.19. So, there is a difference between both of them, but a minor difference. Now, we can see a tree map that represents store types in proportion to their total profit contribution. Over here, let's reduce the size of the tree map. Finally, let's explore the decomposition tree. The third chart in the sixth row is called decomposition tree. Click on it. A decomposition tree is an advanced visualization in Power BI that allows users to break down data hierarchically and explore factors contributing to a metric. This chart helps analyze a metric by breaking it down into different categories step by step. The parameters of a decomposition tree are: analyze, the main value we want to break down; explain by, factors that contribute to this value. A decomposition tree is used in understanding how revenue is distributed, analyzing root causes of performance changes, and drilling down into data dynamically. For our example, imagine you want to understand total revenue across different levels like store country, store state, and store type. Here is how we can create it. Click on the chart, drag total revenue onto analyze field, drag store country onto explain by field, drag store state into explain by field, and drag store type into explain by field. Let's expand the chart for better visibility. Let me click on this option to show you the split of the data. We want to look at the stage of store country. Click on it. Now we can further drill down to look at store state and store type. Click on this plus icon here and choose store state. I'll again click on plus icon and choose store type. Over here, analyze is the metric to be analyzed like total revenue, and explained by are the factors contributing to the metrics like country, state, and store type. Now, we have a decomposition tree that shows revenue by country, then by state, and then by store type. This helps in understanding how revenue is distributed. Finally, each of these charts help visualize data in a unique way, making analysis more insightful. Click Ctrl S to save the changes. This is all about today's lecture. See you in the next lecture. Thank you.